Hello everyone. In this session, let's understand what are destructors. So, when destructors are called and why we need them. So, as the name says, destructors are like opposite to constructors. So, constructors are called when the object is being created, right? So, in constructor is when you write a constructor like this. So, what actually happens in the background when you're creating an object? Okay, let's say you are creating a person object, person. So this is a this will call the constructor, right? So what happens in the background? So when you call person, first it will allocate the memory for the person class. Okay, it will allocate a memory for this person class. So after allocating the memory, that memory has to be initialized. To initialize the memory, it will call the constructor. So that is the main reason why we need a constructor, right? So I hope that is clear. Now, while destruction or when you are constructing, you also need to have a destructive mechanism, right? So in your project, so once the use of this object is over, okay, then this object needs to be deleted, or let's say if the object is goes out of scope, so then uh, there is no need to have memory allocated for that object, right? So that object needs to be deleted, or basically it has to be cleaned up. Memory has to be cleaned up. That is the main reason why we need the destructors. Okay, let's say example. If you let me put an print statement here in the destructor. So this is a person class. Okay, I have written a person class, and in this person class I have written a constructor, copy constructor, some getters and setters, and I have written a destructor as well. So let me write some print statement. Person destructor. Okay. Person obj person new. Okay. You might be wondering why I'm using the wrong one. Okay. Destructor.cp. Okay. So person destructor is called when it is called when this person object goes out of scope at line number 74. So this is where program also ends, but in your project, in a large project, you might be having a different function also. So this different function might be creating a objects void fun, let's say, and this fun is creating a object person obj equals to person. Let's copy the same thing what I'm being. So let's call this fun. So how many times the destructor is called? Any guess? 2 times destructor is called, right? One is because of this, one is because of this. So the number of times the constructor is called, that same number of times the destructor is also called. So that's a rule. Person destructor and person destructor. So one is called inside this fun and the one is called here. So whenever the object goes out of scope, so at the by end of this fun, line number 72, the first destructor is called, and second destructor is called when this obj goes out of scope at line number 80. Okay, so there are different ways of yeah, these are different ways you can create an object, right? So this is one way of creating an object. So this is creation of object on the stack. Okay, if you see this address, this is also a class, this address is also a class, right? So this is also a class, and currently I have not written any destructor, but for this object we are creating an object in the heap, not on the stack, right? So when you create an object on heap, you need to use, to create an object in heap, you need to use this new operator. So it will allocate the memory in the heap. So when you allocate a memory in the heap in your project, you need to delocate that memory by yourself. Otherwise, the memory will not be delocated or memory will not be destructed, right? So for example, this address class person has a pointer of type address, and that address we are allocating a memory for that address and assigning it. Now when person object goes out of scope, okay, if we don't delete this memory, don't delete this address, still it does not complain anything. If you see this, program still works fine. Program still works fine the way it wants, but the thing is that it will not clean up the address which is allocated in the heap for this member. Okay, so these two will never get freed up. This variable, this address is goes out of scope. Okay, it will call the destructor of this address. Okay, if you want to see that, let me write the destructor here. So the syntax of destructor is like this. There's a special symbol in front of the class name. Okay, let's see out address destructor. Okay, so person destructor is called, and here also person destructor is called for this one and this one. There is no destructor for address is being called. Why? Because this address is allocated in the heap memory. So when you allocate a memory in the heap, you need to deallocate by yourself. Compiler will not take care of it, right? So compiler will not take care of deallocation of this memory unless this is a smart pointer. But this is not a smart pointer. This is a regular pointer. In such cases, you need to take care of your memory allocation or deallocation of your memory. Even though you have written a person destructor for person, so for when person object goes out of scope, this will call this destructor. But in this destructor, I am not deallocating the memory for this. So these two are automatically deallocated because these two are stack members. So for stack members, we don't have to take care of the memory deallocation. Whenever this members goes out of scope, or whenever this person object goes out of scope, automatically it will deallocate the memory for those two data members. So, but when you have memory allocated in the heap, you need to take care of it. So for that, you need to use this delete keyword to delete the memory. Okay, so here we are constructing the memory. Okay, and this constructed object is assigned to this person object, which is stored here, and the same reference I am deleting when I'm destructing the object. While constructing, I'm allocating the memory. Okay, well, I'm constructing the person, I'm allocating the memory for address and constructing the object. When this person object going out of scope, it will call the destructor, and this destructor is deallocating the memory whatever is allocated for this address. Okay, I hope this is clear. This is like for to the system memory pool. So we are getting the memory from that system memory and giving it back when our job is done. If we don't do this, it will not complete anything right away, but it will leak the memory. So such problems are very hard to debug because these memory leaks will accumulate as it will keep on accumulate for the time for how much time your program runs. So your program keeps on running 1 hour, 2 hour, depending upon your system memory. So when you keep on creating these person objects, so it will allocate memory for this address. Okay, so how many bytes? One string and one integer. So those many memories are keep on creating, but it is never deallocated even though you are not using it. Okay, so what happens? Your memory keep on accumulating, and you will never be able to get those memory back because this person object is going out of scope, but you don't have reference to this address because this address also going out of scope. So you don't have any mechanism to get back that memory. Okay, until unless you restart your program, which is a very costly operation in the production system. So this will lead to a very bad behavior or undefined behavior when your system memory goes completely out of scope, 90% or 100%. So your system will crash. So these memory related problems are very hard to debug, or very dangerous. So it is always best practice, or it is always better to be very careful when you are dealing with the memory. So you have to remember that when you allocate a memory, it has to be deallocated somewhere. Okay, so that's where this destructor is very useful. So you don't have to remember uh, you don't have to remember when I have to deallocate the memory. You can just inside this destructor, if you have a data members which is of pointer type, and the pointers are allocating memory in the heap, so you just put in its destructor the cleanup code, so that whenever that person that object is going out of scope, automatically your memory is getting deleted. So this is one best practice. All right. uh, but this has another implication when you are doing a shallow copy. So the shallow copy also has to be avoided. So in the previous session, or in copy constructor session, we have seen the shallow copy implications without writing copy constructor. If you write this, so for two objects are sharing same address, I mean when you copy one object to another object, the two object will be sharing same address. So that time it will lead to a double deletion operation. So you need to take care of that. So what are the best thing you can do when you have a pointer in your class? You have to have a copy construction copy constructor, and you need to write your own destructor, not to depend upon the compiler generated destructor. You need to write your own destructor and clean up your code. Okay, and you also need to write copy assignment operator that will uh, I'll explain in the another session. So let's compile this. So I have deleted this now. So let's see the output now. So you see, now it is calling address destructor. Address destructor is called when immediately after the person destructor is called, right? So first time for this object, when this object goes out of scope, so person destructor is called. After that, when it hits this keyword delete address, it will call the destructor of the address class. Okay, so always remember, when you're creating a memory on heap, you need to use delete keyword to delete it. Only then the destructor of that class is called. So if you allocate a memory in heap for address, you need to do allocate a memory for address using delete keyword. Okay, so new and delete are the combination of construction and destruction of the objects. So these are the two ways how you can construct the object in stack and heap, and how you can destruct the object in stack and heap. So I think that's all for the destructor. So there was some more concept with related to destructor, like virtual destructor and all those things. We'll explain all those things in the upcoming session when we are handling the polymorphism. That's all for now. See you in the next session. Thank you.